This is the video for section 6.4, and this section is going to introduce simplifying um, roots, and we're used to simplifying square roots, but this lesson introduces symbolizing, um, simplifying any kind of root. Okay, so we're going to go over some basic terms first. Here's the first term. Okay, so far we would have things like square root of 9. Okay, and we know the square root of 9 is 3. Well, anytime we wanted to find the square root of something, we just assumed that there was a little 2 here. This 2 is called the index number. And when there's not an index number there, we just automatically knew that we were supposed to find the square root. Well, in this lesson, we're going to talk about the nth root. Okay, so this right here is the index number. What the number inside is called the radicand. And then, of course, we have our radical sign. All right, some numbers have more than one real nth root. For example, 64 has 2 square roots, 8 and negative 8. Okay, since 8 squared and the quantity negative 8 squared both equal 64. Okay, when there's more than one real root and n is even, the non-negative root is called the principal root. So some examples of nth roots are listed below. So the square root of 25 is 5. Square root of 25 indicates the principal square root of 25. When I have a negative out in front, okay, the negative indicates the opposite of the principal square root. So we know my answer would be negative 5. And then the plus or minus out in front indicates both the positive and negative. Okay, so in today's lesson, if I have x to the third equals 64, I'm looking for a number times itself 3 times to give me 64. Well, it's 4. 4 times 4 times 4 is 64. So 4 is a cube root of 64. And another way to write that is this. The cube root of 64 is 4. Okay, x to the fourth equals to the 625. So 5 times 5 times 5 times 5 equals 625. That means 5 is a fourth root of 625, and here's how I'd write it. The fourth root of 625 is 5. We can have fifth roots. Okay, x to the fifth equals 32. Well, 2 times 2 times 2 times 2 times 2 is 32. So 2 is a fifth root of 32, and I would write it like this. Okay, so today's lesson, we're going to find different roots of numbers. So let's look at some examples. We want to simplify the following. So first of all, this example A, I'm going to have a plus or minus out in front of my answer. And this is just a regular square root problem. So we've done problems like this all the time. So the square root of 16 we know is 4. If I have y to the fourth, remember we're looking for groups of 2. Okay, so how many groups would I have? Well, I would have 2 groups. And so this is my answer. Okay, in part B, I'm still just looking for the square root. I have a negative in front, and that's okay. I can have a negative. Now, we haven't really seen problems like this. If I think about this, this means I have x minus 6 written down 8 different times. I'm not going to write 8 of them, but you see what I'm doing. And remember what we would do? We would look for groups of 2. So I'm looking for groups of 2. So if I have 8 of these and I am looking for groups of 2, I would have 4 groups that I can take out. So this would simplify down to x minus 6 to the fourth. Okay? Now in example C, my index number changes. I'm not looking for the square root anymore. I'm looking for the fifth root. So when I break things down, I'm looking instead of for groups of 2, I'm looking for a group of 5. So I don't know what this is just by looking at it. So I'm going to break 243 down. Okay, well 243. I'm going to just divide it by 3. Well, 3 will go into that 81 times. So I know this is 3 times 81. And now I'm going to keep breaking this down. 81 is 9 times 9. 9 is 3 times 3. Okay, so I'm done breaking down 243. I'm looking for groups of 5. So I have to have 5 in a group in order to take it out from underneath the radical. Well, I just happen to have 5 threes. So I'm taking out all of these threes. Okay, so far I know I can take out a 3. I have a to the 20th, which means I could list 20 a's out here, but I need groups of 5. So how many groups would I have? I would have 4. Now let's do our b's. I have 25 of them. So groups of 5s, I would have 5 of them. So 3a to the 4th, b to the 5th is my answer. Okay, let's do one more like that. Okay, square root of negative 16x to the 4th, y to the 8th. Well, first of all, I have a negative inside the square root sign. Okay, well, we know that we cannot have a negative square root. Now, here's what we have to be careful with. I could have this, because look, 8 is negative 2 times negative 2 times negative 2. So when I have an odd index number, a negative underneath the radical is allowed, because a negative times a negative times a negative is a negative. Okay, but I cannot have a negative underneath the square root or any even index number. So I could go ahead and simplify this. I know the square root of 16 is 4, but I know the negative means it's going to have an I with it. So plus or minus 4i, and then this would simplify down to x squared y to the 4th. Okay, that's kind of a weird problem. You wouldn't see those very often. All right, let's do some more simplifying. Now, we're going to introduce a new rule. Okay, and here's our new rule. When you find an even root of an even power, so here's an example. Here's an even root of an even power. Here's an even root of an even power. An even root of an even power. Okay, so that's what they're talking about. So when you find an even root of an even power, and the result or your answer is an odd power, you must use the absolute value of the result to ensure that the answer is non-negative. Okay, so here's what I'm talking about. First of all, I need 4 in a group because 4 is my index number. I have 4 y's, so my answer would be y, and that would be y to the 1st. So look, I had an even root of an even power, and my answer was an odd power. So my answer is going to be not just y, but the absolute value of y. Okay? Because y has to be positive for me to be able to do this. All right, let's do this. First of all, my index number is 6. All right, so I need groups of 6 to take out. So 64, let's break that down. That's 8 times 8. 8 is 2 times 2 times 2. And my other 8 is 2 times 2 times 2. So do you see I have a group of 6? So I know I can bring out a 2. Okay, this is a group together, and I have 18 of this x squared minus 3. So how many groups of 6 would I have? Well, I would have 3 groups. So now let's look. I had an even root and an even power, and my answer right here was an odd power. So I need absolute value bars around this right here. Okay, so that's my answer. Let's do this one. My index number is 4, so I need a group of 4. 16 is 4 times 4. 2 times 2, 2 times 2. So you see I have 4 of the same number. So I can bring out a 2. I have 12 x minus 3's. I need 4 in a group in order to take them out. So I would have, how many groups left? 3. So I had an even root of an even power, my answer was an odd power, so I need absolute value bars around this part of my answer. Okay, so when you do your assignment today, everything will be able, when you simplify, you will have nothing left underneath the radical sign. And all of your problems today, they're all going to simplify to where you will have nothing left. And then later on, we'll have some that are that you'll have things left underneath the radical, but not for today's assignment. Okay, the last problem. The surface area of a sphere can be determined from the volume of the sphere using the formula, and here's the formula. Surface area is the cubed root of 36 pi v squared, and v is the volume. Determine the surface area of a sphere with a volume of 200 cubic inches. Okay, so S equals, this is going to take the place of my v. So I have the cubed root of 36 pi v squared. So that's going to be 200 squared. Yeah, come in. Okay, sorry, someone came in, so I don't remember exactly the last thing I said, but we plugged 200 in for v. Now this just becomes a calculator problem. So let's put this in the calculator. Now here's the deal. If you notice, okay, we've always had this square root button, but this isn't square root, this is the cubed root. Well, you also have a cubed root button on your calculator. It's under math. See number 4? There's my cubed root. Okay, so I'm going to type in 36 pi, and pi is your second, and house top right here. Oh shoot, I didn't get my second button. So second, house top, 200, and then my squared button equals, okay, 165. And that's my answer for the surface area. So my surface area is around 165 square inches. So now that says if the surface area of a sphere is 214.5 square inches, determine the volume. So now they've given us S. So again, I'm using this formula, but I know what S is. S is 214.5 equals the cubed root of 36 pi v squared. So now we have to solve for v. Now v is underneath this cubed root. Okay, so I have to get it out from underneath that cubed root. And to do that, we cube both sides. Okay, so let's see what 214.5 to the third power is. So 214.5 cubed. So house top 3. So I know that's a long number, but we're going to go ahead and write that number down. So it's 98619. That's a 9. 8.625 equals, now when I cube the cubed root of something, I get what's underneath, 36 pi v squared. Okay, now I'm going to solve for v, so I need to divide by 36 pi. Okay, so let's go ahead and, well, we'll wait. So I get v squared equals this whole thing. Okay, and we'll put that in our calculator, I guess. So I already have this in my calculator, that top number. So I'm just going to put divided by. And when I put 36 pi, I'm going to put 36 pi in parentheses. And I get 87262. So 87262.87475. Now that's what v squared equals. So to solve, I'm going to take the square root of both sides. So I need to take the square root of that number. So that number is still in my calculator. So now I'm going to hit second and then my square root button. Now I don't want to have to type that number back in, so I'm going to hit second, and then see your bottom right here where it says answer equals 295. So volume is 295.4 cubic inches. Okay. Now there's one other type of problem, and it's a calculator problem, and I'm going to show that to you in class.